Alright, so welcome to part 2. Let's just get started. So part 2 and I guess part 3 and 4 as well are basically going to be on two group tests. Alright, at least that's what I call them. Basically, there'll be questions that involve not one group, but instead two groups of data. So in part 1, we basically discussed questions that maybe only used one group of data. These will be using two groups, alright? And so these are the 5 different questions that you'll be seeing, at least in subjects 2, 3, and 4. Right? You have the paired parametric question, the paired non-parametric question, non-paired non-parametric question, the non-paired parametric equal variance question, and finally the non-paired parametric different variance question. Alright? And I'll just be referring to these as question 1, 2, 3, 4, and 5. Alright? So just for part 2, we'll be only discussing the paired parts, or the paired sections, and that includes question 1 and 2. So this is just a diagram that I made, and you can kind of see it's a bit messy, but you can see the paired, not paired, and then the different like parametric parts and stuff like that. But again, part 2, we're only going to be discussing the paired section right now. And as well, you can see the little equations that you use to find the either the z or t statistics and the p-values. But let's just get into it. So first question is, well, how do you know if the data is paired or not? All right. And so generally this is pretty easy, but we'll use an example and just make it easier to describe. So the example is, does driving a BMW car make you speed more than driving a Honda car? All right. So what a paired question would look like it'll basically have data that looks like this, right? So for the BMW group and the Honda group, the drivers in this case are the same, all right? And so that's what a paired question is essentially if the two groups of data uh, use the same people or the same subjects in each group, all right? Now a non-paired question will have data like this. So in this case, you can see that the BMW group has drivers 1, 3, 5, 7, blah blah, and the Honda group has drivers 2, 4, 6. So you can see basically a non-paired question has two groups with independent people, all right, that are not used between each of the groups, all right. Another way to like tell if the data is not paired is if the groups have different ends or different amounts, right? So let's say if the BMW section only had, I don't know, 20 drivers, let's say. If the Honda group had, let's say, like 25 or 30, then you obviously know it's not paired, right? So, in any case, this is basically how you tell, and so this is important. It'll obviously let you know which tests to do depending if the data is paired or not, right? Right, so again, back to this group. So now that you know what paired or not paired is, now you can continue on. But again, obviously, we're doing only paired questions right now, so we'll now discuss how to know if you have to go through the parametric question or the non-parametric question, right? So what is parametric, right? Well, essentially, what it means is that since we're doing a paired test, or that we're doing the paired section, essentially has to do with the sample pairs, all right? So to know if your data is parametric, basically, if the differences between group 1 and 2 are normal, then it's parametric. Or if the sample pairs are greater than 25, then that's also parametric, right? So back to the example of like the BMW Honda group, if there are 25 or more drivers, then that's parametric. And if the differences between the two groups is normal, then it's also parametric, right? So it's one or the other. And to find out how the differences are normal or not. Uh, Again, similar to subject or part one, you'd use the Anderson-Darling test or just the AD.test, right? And in this case, you would do the group 1 minus group 2 within the AD test, right? And as always, to be normal, the p-value must be greater than 0.005, or in this or alpha, I should say. Technically, it should be greater than alpha. So, uh, but generally, alpha is 0.05, right? So now into the questions. So for question one, the paired parametric, basically you'll just do the equation right here. So you have the you'll be using a t-test, and the important part is that when you're doing this, you make sure that the paired equals t, or true in this case. So this basically signifies that uh, you're using a paired group, alright, groups. So make sure you do that, and then yeah, that's how you solve this. And as well, you can see the lower-tailed, upper-tailed, and two-tailed examples. And so for the second question, the paired non-parametric, this time you'll be using the Wilcoxon signed ranked test. Don't know why it's called that, that's just how it is. And instead of a t statistic, it'll be using a z statistic, alright? And similar to the last question or question one, instead of using t.test, you're using wilcox.test, but the rest of the data is still the same. And again, you do paired equals t, alright? However, the big difference, alright, is that you have to put exact equals f or false, right? If you don't do this, your data will be, or like your p-value and your z-statistic will be slightly off, and it'll basically make you get the wrong answer, right? So just make sure you always do that exact equals f, alright? And yeah, that's basically it for part two. Part three will cover the non-paired questions. But yeah, see ya.